cinematic documentary entitled The Secret of the Before the Big Bang. Screenplay written and directed by Sayari Abdelkhalek. Imagine for a moment. Close your eyes. There is nothing. No light, no stars, no galaxies. Not even the icy void of space as we know it. There is neither up nor down. Neither yesterday nor tomorrow. It is absolute silence, a total absence. It is within this inconceivable nothingness that the greatest of all questions lies dormant. What happened before the beginning? Before that incredible moment, 13.8 billion years ago, when everything we see, everything we are, burst forth from an infinitely dense and hot point. This is the mystery of before the Big Bang. This question fascinates us all, doesn't it? It takes us back to that childhood curiosity. Where do we come from? But here, the question is even broader. Where does come from? Did time itself have a beginning? Did our universe emerge from nothing, like a magician pulling a rabbit from his hat? Or is it merely the latest link in an endless chain? A universe reborn from its own ashes, again and again? These questions are not just scientific. They touch on our place in the cosmos. They are profoundly philosophical. That's why they captivate physicists in white coats just as much as thinkers and poets. The Big Bang is not an explosion in space, as we often imagine. It's rather an explosion space itself. Space and time began to expand from this primal singularity. So, to ask what came before is a real conundrum. How can there be a before if time itself didn't exist yet? It's like asking what lies north of the North Pole. The question seems to make no sense according to our own rules, and yet, the human mind cannot help but ask it. It is our nature to want to peek behind the curtain, to seek the first cause. This mystery is the starting point of an extraordinary quest. It is an adventure of thought that pushes us to the limits of our imagination and understanding. Scientists, armed with their telescopes and equations, try to rewind the film of the universe back to its very first frames. But the closer they get to the zero moment, the blurrier the image becomes. The laws of physics we know, those of Einstein and general relativity, cease to function. It's as if nature is saying, "Stop, you cannot go further with these tools." This is where the true challenge begins. To understand why this question is so hard, we need to talk about an almost impassable barrier. Physicists call it the Planck wall, or the Planck era. It's an incredibly tiny fraction of a second after the Big Bang, so small that it can barely be written with zeros. Imagine, 10 to the minus 43 seconds. Before this moment, the universe was so small, so hot, and so dense that our current theories break down. Gravity, described by Einstein, and the quantum world, the realm of the infinitely small, come into conflict. The two theories do not speak the same language, and to describe the primordial universe, we would have to unite them. It's a bit as if we had two extraordinary maps, but for two different continents. One, general relativity, is perfect for describing the infinitely large planets, stars, galaxies. The other, quantum mechanics, is brilliant for the infinitely small atoms, electrons. But at the origin of the universe, everything was both infinitely small and infinitely dense. The two maps should therefore overlap. Yet, when we try to make them coincide, we get absurd results, infinites that have no physical meaning. This theoretical wall prevents us from seeing what was before, but scientists do not give up. They work tirelessly to construct a new theory, a theory of everything. It would be the holy grail of physics, a theory capable of unifying gravity and the quantum world. It is often called quantum gravity. If one day we manage to formulate it, we might finally have the right mathematical tools to describe the universe at its very first instant. Perhaps this Planck wall is not a definitive wall, but simply a door for which we have not yet found the right key. It is one of the greatest undertakings in 21st century science. While waiting, all we can do is imagine. Theories about before the Big Bang are, for now, hypotheses. They are not pure science fiction. Be careful. They are based on very advanced calculations and ideas from the most cutting-edge theories we have. But they remain difficult, even impossible, to prove with our current technologies. They take us into a realm where science flirts with imagination. It's a fascinating journey to the borders of knowledge, where every idea opens dizzying perspectives on the very nature of reality. So, what do these theories tell us? One of the most intriguing ideas is that of the quantum vacuum. According to quantum mechanics, the vacuum is not truly empty. It is filled with a kind of trembling energy, where pairs of particles and antiparticles appear and disappear constantly in a fraction of a second. These are called quantum fluctuations. Some physicists think our entire universe could be the result of one such fluctuation, but on a gigantic scale. The universe would have been born from almost nothing. Not absolute nothingness, but a kind of creative potential. An ocean of energy ready to boil over. Another avenue speaks of a cyclic universe. This is a very ancient idea, found in some Eastern philosophies, but revisited by modern science. In this scenario, the Big Bang is not a unique beginning, but just a stage in an eternal cycle. Our universe would have been born from the ashes of a previous universe. It expands, cools, and one day, perhaps in trillions of years, it will contract in on itself in a big crunch. All matter and energy would gather into a single point before bouncing back in a new Big Bang, giving birth to a new universe, and so on, for eternity. And what if our universe is not alone? This is the multiverse theory. Imagine a vast bubble factory. Each bubble that forms is a universe, perhaps with its own physical laws, its own particles. Our Big Bang would be but the birth of our bubble universe, among an infinity of others. Some of these bubbles would collapse immediately, others would be sterile, and a few, like ours, would have the right conditions for life to appear. This idea is fascinating because it would answer the question, why is our universe so well suited for life? The answer would be simple. Because we exist in one of the rare universes where it was possible. These three ideas, the birth from quantum vacuum, the eternal cycles of the Big Bounce, or the infinite sea of the multiverse, are all more incredible than each other. They show us just how much reality could be stranger and vaster than anything we can imagine. None are proven, of course. They are avenues of research, mathematical models that try to make sense of the clues we gather. They force us to rethink fundamental concepts like time, space, and even the notion of a beginning. Which one is right? Perhaps none. Or perhaps reality is a mixture of all of them. This quest for origins is a remarkable crossroads. It is where the most advanced physics meets the oldest questions of philosophy. For millennia, philosophers have wondered, why is there something rather than nothing? Today, physicists are asking exactly the same question, but in a new language. That of mathematics and observation. The equations of string theory or quantum cosmology are the new poems that try to describe the indescribable. Science does not steal these questions from philosophy. It offers new tools for reflecting on them. Yet humility is required. Science has its limits. The very nature of the scientific approach is to test hypotheses through experiment. How can we test what happened before the Big Bang? By definition, this before is causally disconnected from our universe. No signal, no information could have reached us from that elsewhere or that before time. We are like investigators arriving at a crime scene where all evidence prior to the event has been erased. We can deduce what happened just after, but the precise moment of origin and what came before remain out of direct reach. This link between science and philosophy reminds us that knowledge is not just an accumulation of facts, it is also a search for meaning. Knowing that the universe sprang from a quantum fluctuation or that it is part of a multiverse does not answer the question, why? It simply pushes the mystery back one step. Where does the quantum vacuum come from? What laws govern the multiverse? Science describes the how with ever greater precision, but the ultimate why always seems to slip away. And perhaps It is this tension between knowledge and mystery that is the true driving force of human curiosity. That is why these theories, even unproven, are so important. They nourish our imagination. They force us to be creative and to consider radical possibilities. They show us that the universe is far more complex and wonderful than our senses let us perceive. They invite us into an ongoing dialogue between what we know, what we can prove, and what we can only imagine. This shifting frontier between physics and metaphysics may be the most stimulating place for the human mind. It is where the greatest revolutions in thought are born. In the end, the mystery of before the Big Bang remains intact. We have clues. Dialogue, human and echo of the universe. Human.
Tell me, what was there before the beginning?
Echo of the universe.
You're looking for a before, in a place where time didn't yet exist.
Human.
So, the mystery is eternal?
Echo of the universe.
No, the mystery is you.
All rights reserved to the author. Regards, Sayari Abdelkalek.